The ocean floor here is not rock. It is silence, absolute and ancient. Pressure compresses the water above 11,000 meters of it, a weight of 1,000 atmospheres. The water itself feels thick, viscous, as if pressing against your skin. Sunlight vanished here millions of years ago. No light, no warmth, only the endless, suffocating dark. You hear the groan of metal, the slow creep of pressure on the hull. This is the deepest scar on Earth, untouched by the sun. Jack Pickard and Don Walsh descend in the Trieste, a small, fragile bubble of steel. The descent takes 4 hours. The depth gauge ticks 10,000 meters, 11,000. The bathyscaphe shudders, metal groaning under the strain. Outside, blackness swallows the viewport. Inside, the air is thick with tension. They reach the bottom at 8:15 a.m. on January 23, 1960. For 20 minutes, they rest on the sediment, the first humans to touch this abyss. The world above holds its breath. Below, only the crushing dark remains. 32 years later, the same abyss calls again. James Cameron descends alone in the deep-sea Challenger. His submersible pierces the black, lights cutting through the absolute dark. The descent takes 3 hours. The pressure is constant, a physical presence. He lands gently on the soft, muddy bottom of Challenger Deep. The cold is near freezing, the silence profound. He places a flag on the sediment, a single point in the eternal dark. The world watches as one man walks the edge of the known. Life pulses in the black. Microbes cling to rock, bioluminescent in the faint light of Cameron's cameras. Amphipods, shrimp-like scavengers, scuttle over the mud, feeding on the slow fall of marine snow, organic debris drifting down from the sunlit surface. They thrive under crushing pressure in near-freezing water. Life, simple and ancient, endures where humans only visit. It has been here for millions of years, untouched by the sun. The trench holds its secret deep within the silence. The depth is measured by sonar echoes bouncing off the abyss. Pressure is recorded by sensors that withstand the crush. At 11,000 meters below, Challenger Deep is a bottomless void. Sunlight never penetrates the ink. Water presses with over a ton per square inch, enough to flatten a car like foil. Historical dives confirm this. Trieste's 1960 descent, its metal hull groaning under the weight. Cameron's 2012 solo journey, his submersible's titanium sphere holding firm. The seafloor isn't rock, but soft sediment, undisturbed for millennia beneath the eternal night. Geologists mapped the trench's origin through seismic waves. It formed where the Pacific Plate dives beneath the Mariana Plate, a slow, violent slide over millions of years. This process, subduction, sculpts the trench. Seafloor mapping reveals clear fault lines, a jagged scar on Earth's crust. The trench's shape matches plate movement models perfectly. It's not random. It's Earth's skin tearing, folding, and sinking under its own weight. Life pulses in the black, unseen. Microbes form pale mats on basalt rock, using hydrogen sulfide from hydrothermal vents as fuel. Amphipods, shrimp-like scavengers, scuttle over the mud, their eyes dark pits in the black. They feed on marine snow, tiny flakes of dead plankton and fecal matter drifting down from the sunlit surface, a slow, silent rain. They thrive under crushing pressure, their bodies resistant through specialized proteins. Scientists have isolated these proteins, revealing how life adapts without light, without oxygen from the air. The trench's secrets deepen. How do microbes survive with such low energy? Some bacteria break down minerals like pyrite, releasing oxygen for energy. Others share nutrients in dense, interdependent colonies. Yet the full ecosystem remains hidden. We've only sampled the surface of this dark world. The deepest parts hold more undiscovered life, adapting in ways we barely begin to grasp. The silence here isn't empty. It's humming with ancient processes, holding answers we haven't learned to hear. Pressure gauges vibrate at 1,000 atmospheres. Inside the deep-sea Challenger asterisk, the hull groans like a living thing, a deep thrumming felt in the jawbone. Outside, the water is a near-liquid vacuum at 2 degrees C. Sunlight died 10,000 meters above. Only the faintest bioluminescent pulses from microbes pierce the absolute black. This isn't a home. It's a pressure cooker forged by Earth's own weight. The silence is thick, heavy with the sound of crushing. Life here defies the math. Hydrogen sulfide from vents and pyrite breakdown provide barely enough energy for basic microbial functions. Marine snow, the slow drift of dead plankton and waste from the sunlit world, falls too sparsely to support the observed density of amphipods. Scientists sequence the microbes' genes, mapping their metabolic pathways, but the energy calculations don't align. The biomass asterisk should asterisk starve, yet it thrives. The missing energy pathway remains a silent void in our understanding. Current exploration is a whisper against the scale. The Trieste and Deep-Sea Challenger only touch the trench's lip, their lights illuminating a fraction of the sediment-covered abyss. We've never observed the deepest, coldest zones, where pressure is highest and life is most concentrated directly. The true ecosystem, buried under meters of fine, dark silt, remains hidden. Our samples are surface scratches on a vast, uncharted continent. The silence hums with life we cannot yet measure. To resolve this, we need a network of sensors embedded deep within the sediment, tracking energy flow in real time. How much oxygen do microbes extract from minerals? How do nutrient-sharing colonies function across the vast, dark distances between them? Without this direct observation, we're reconstructing a complex symphony from a single, isolated note. The trench holds answers, but we haven't built the tools to hear them yet. What other life thrives where no light has ever touched?